by this other integral, which is extra t here, right? And we have another video explaining the half angle for the tangent function. This is a substitution that we are going to use today. This substitution also comes with the streams that we have here. What happened with theta is 0, t in this case will be 0 also. If theta is going to 2 pi, then t is also going to infinity. And I explained why that happened in that video. So today we are going to resolve this integral, which is kind of similar, but with the extra component here that we have a trigonometric function, the cosine of theta, right? This a, it could be any number, whatever number that is the absolute value is less than 1. Okay, so let's start doing this substitution that we have here. Let's do it. We have from 0 to infinity, as I explained it a second ago. Let's put it this 1, and below we have 1 plus a that multiply cosine of theta, which is this, right? Put it 1 t squared over 1 plus t squared, and everything is squared also, multiplied by the theta, right? The derivative of theta here, which is 2 the derivative of t over 1 plus t squared, right? So let's expand this part that we have here a little bit more. Let's put it here. Let's do 1 plus a that multiply 1 minus t squared over 1 plus t squared. This is equal to, this part I have to multiply it by the 1, so we have 1 plus t squared plus a, this minus a plus t squared, right? And this in the denominator we keep 1 plus t squared. And this part we can still obtain this t squared here, so we will have 1 plus plus a plus 1 minus a t squared, right, over 1 plus t squared. Then let's come back to the integral that we are gonna solve here. We go from 0 to infinity of, again, it's super big, 1 plus a plus 1 minus a t over 1 plus t squared square. 2 for the derivative of the 1 plus t squared, right? And I think we can put this in the top because this is the denominator of the denominator will become the numerator. So we have 0 to infinity, right? We have 1 plus t squared over 1 plus a plus 1 minus a t squared, everything squared, multiplied by 2 derivative of t over 1 plus t squared, right? So we can simplify one here and one from here. And what do we have now? So we have 0 infinity. Remove everything here to 1 plus t squared derivative of t over, what is this? We have 1 plus a plus 1 minus a t squared square. And now we can actually do a trick. If we substitute, let's say b 1 plus a, right, and c 1 minus a, then we can have our integral like this, to integral from 0 to infinity. Remember that a is a number, so this b and c are also numbers. Different numbers, but they are numbers also. So we will have 1 plus t squared, right, over b plus c t squared the derivative of t. And we can separate this into integral because we have this addition in the numerator. So let's do it. We have then the integral from 0 to infinity. Let's put the 2 at front, right? That is going from the dt. Let's move this a little bit. B plus c t squared plus 2 from 0 to infinity of t squared derivative of t of b plus c t squared. And this actually looks like what we have in the top, right? Basically this one is the same that we have here. This one is the same that we have in the other side, right? Let's continue. I forgot to put this in the top. Okay. Let's do it. So we have the solution for this will be these two that we have here. We put it in the front. That multiply by, right, 4. In this case, this b will be my a here, so let's put it here in at the front. B 3/2, C 1/2 plus 2 that multiply these two that multiply the solution of this, which is the one that we have here, pi 4 B 1/2 C 3/2, right? So we need to simplify this answer. So we did, that is already an answer, but I see that this one could be simplified. We have pi everywhere. We also have b and c that repeats everywhere. So we can take out all this. Let's put it here. Let's put we have pi, we have also 2 that multiply. I think 3.5 will have at least one complete b plus 1/2 extra. The same thing for the c 3.5. So let's do it. 2b.5, because we have 1/2 everywhere, and c.5, and we will end up with 1 over b plus 1 over c. And we can simplify this, to do the operation. We'll have here 2b 1/2 c 1/2, right? Multiply c plus b bc, right? But let me see. Okay, and we can still multiply this one again. We will have pi over 2, right? And multiply c plus b over b 3.5 and c 3.5. Because they have the same exponent, we can combine that. Let's see. We can have pi over 2 that multiply, let's put it here, c plus b, and in the bottom we have a bc elevated to the exponent 3.5, right? But what is c and what is b? We have the substitution here, so we can get back the substitution in place, and we will have pi 1 minus a, right, plus 1 plus a. We have here 2 that multiply 1 minus plus a, 1 minus a, sorry. Everything elevated to 3.5. We can get rid of a in the top, and we will have 2 pi that multiply by 2. And what is this? This is the binomial factorization rule, right? So this is the 1 square minus a square, right, elevated to the 3.5, and we can get rid of these 2, and finally the solution for our integral is this 1 minus a squared elevated to 3 square. Okay, thank you.